Good day. This is Mr. Matthew, taking mathematics. And the topic for today is set theory 1. Because I'll be presenting 2 of it. And these are the objectives. To define the sets, 1. Identify types of sets and give examples. 2. Venn diagrams and interpretation of them. Determine and write the number of elements of a set. And lastly, find the union and intersection of sets. Definition of sets. A set is the collection. A set is the collection of well-defined objects or elements and denoted by capital letters and represented in Venn diagrams by rectangles and circles or ovals. Examples. A is this set 1, 3, 5, 7, 9. B is the set of this even number 2, 4, 6, 8, 10. Y, the universal set, is 1, 2, 3, so on and so forth, up to 10. That's 1 to 10. Here, A and B are subsets. That means of the universal set. That means they are inside the universal set. Universal set is the set containing all the one we are considering. That's 1 to 10. The number of elements in A, represented as NA, is 5 if you count by counting. And that of the number of elements for B is also 5. While that of the universal set, you have 10. The number of elements there are the numbers of elements in A, that's set A, B, and the universal set respectively. And this is the Venn diagram. This is the set for A. Either you circle or over. You can see it's 1, 2, 3, 1, 3, 5, 7, and 9. While that of B is 2, 4, 6, 8, 10. So B even, while A is odd. You can see all the elements are there from 1 to 10. This is the universal set. And this is called Venn diagram to honor the man that to honor John Venn. Now this is assignments to classwork for you. Exercise 5A, number 1 to number 7, New General Mathematics, SS1, on page 68. Elements of a set. Elements of a set. Example. List the elements of the set. A. Even numbers less than 50. While B. Natural counting numbers, or what we call natural numbers. Here it's represented as B, but in most cases we use capital N to represent it. Now these are the solutions. Even numbers. The first even number is 2, followed by 4, 6, 8. Less than 50. Since it's less than 50, the one next to 50 is 48. So this is the set of even number less than 50. That of the natural numbers, natural counting numbers. So the first one is 1, 2, 3, 4, and so on. It means it's continuous. This is the set of natural numbers. Now, if W equals whole numbers between 2 and 10, find NW. Since it's between 2 and 10, that means 2 and 10 are not included. We start from 3. The solution W equals 3, 4, 5, 6, 7, 8, 9. 10 is not there. Now, the number of elements, we also find the number of elements. So NW is 7 by counting. So we have 7 of them. And that is the solution. We'll move on. Equal sets. Equal sets. Two sets are equal if they have the same, exactly the same elements. They have the same element. You know that equivalent set also is a subset of equal sets. So once two sets are equal, they are also equivalent. They are also equivalent. Now, example. S is given as this set. Capital S, B, first element B, A, D, C. If S is that, which of the following sets are equal to S? P has A, has B, A, D, C, A, D. And Q has D, A, C, and E. Now, R is the first 4 letters of the alphabet. And these are the solutions. You can see that all the elements you have in S is in P. A is there, D is there, C is there, and B is there. So, S is equals to P. So, the first one is correct. S is equals to P. So, let's see Q. In Q, there's something that is different. There's no E. There's no E in S. But there's E in Q. So they are different. They are different. So S is not equals to Q. But Q is equivalent to S. That means they have the same number of elements, 4, 4. They are equivalent. They are not equal. Now, for R is equals to X, because all the elements you have in S, you also have in R. So equivalence to is also implied. Once they are equal, means that 4 of them are equivalent to each other. Or they are equivalent. Now I move forward. Now this class work for you. Stroke assignment, exercise 5B, number 1 to number 6. New General Mathematics, SS1, on pages 69 to 70. Assignment. Now, I move forward. I want to define empty set, finite and infinite set. From the word empty set, means it has no member. It's a set without any member and is denoted by phi. This phi or this. You can see it's empty. Nothing is inside. And the number of elements of phi, you should know, the number of elements of this phi is 0. Is 0. It's also a subset of itself. It's a subset of the universal set, meaning that it's contained in itself. That's improper subset. It's also contained in the universal set. It's contained in every other set. It's a proper subset of every other set. Example of empty set is squares with 5 sides. We know it is impossible for a square to have 5 sides. It has to be 4. So this set is empty. It's equals to 5. 2. Nigerians who are 2 meters tall. We don't know about 2 meters. 20 meters tall. We know it's not possible for us to have anybody as tall as to be 20 meters tall. So this set is empty. College student, see, of age 3 is very rare. It's an impossible. So this one too is 5. It's empty. I'll move forward. Now, what is finite? A set is finite. Finite. Finite set has definite number of elements. It has definite number of elements. That means you can count all its elements. You can count all the elements. They are countable. You can count all of them, every one of them. While infinite set has indefinite number of elements. You cannot finish counting. You cannot finish counting all the elements. Like y now. This y you see. Y here, you can see showing that this 1, 2, 3, 4. This is a set of natural numbers. 4 and so on. It means it's continuous. It's unending. It's an infinite set. It's an infinite. You cannot list all its elements. An infinite set. Another infinite set is integers. Positive and whole number. You cannot list all of them. YD, that is having only 3 elements, you can see, you know there are 3, only 3. 1, 2, 3 is finite set because it has definite number. You can count it. It's finite set. Now I move. Now subsets and universal set. Universal set is the set containing all sets at a particular time. It is denoted as U or E and represented by rectangle or square. While subsets are sets that are contained in a universal set, such as A, B, C. You can see this is the symbol for subset inside the U. We represent a subset with either circles or ovals. Not like as I've drawn in the Venn diagram. Example, given that U has the element from A, B, C, D, E, F, G, H, I, J, yes, while V is vowels, and C is letters of the word cabbage, and H is the letter of the word heed. Question 1. List the members of V and C. B. Draw the Venn diagram of the above. This is the solution. The universal set. Among this universal set, the vowel, we have A. E, and I. Since this is the universals, we're only considering from A to J, not the entire alphabet. So it has only 3. A, E, and I from the universal set. Then the garbage, the letters of the garbage, since we don't need to repeat them, we only have 5. C, A, B, G, E. So it only has 5. Whether you repeat them or not, it's 5. Now we are counting. We don't repeat. We count one element once. Now this is the Venn diagram. This is the universal set inside this rectangle. The entire rectangle. Now we have this is V, this is C, and Y, this is H. This is H. Garbage, 5. V, I is in H. You can see this id. That's the set H, the vowel. As A, E, and I. This E, I is common to both the vowel and the garbage. So this is the Venn diagram. Very important. But I is common to vowel and head. Very important. So that's the Venn diagram. This has 3 subsets. Now, assignment. Exercise 5D, number 1 to number 10. General Mathematics SS1 on pages 71 to 72. Now, union and intersection. The union of set A and B, denoted by this. This is the symbol for union of set A and B. We use U. Is the set containing all the elements of A and B. All the elements of A and B. While intersection of A and B, denoted as this. A intersection B is the set that contains element common to the two. Common. What is common to the two is in A, at the same time it's also in B. What is common to them? Example. A is 1 to 3. B is 2 to 6. Find A intersection B and A union B. And these are the solution. It's only 2 and 3 common to them. So this is the intersection. Then what is in both A and B is 1 to 6. 1, 2, 3, 4, 5, 6. That's the union. And this is the Venn diagram. This is the Venn diagram. This is the intersection. This region is represented by the intersection. A intersection B. Only this region. That's A intersection B. The entire A, B, everything you can see 1 to 6 is there. That's their union. So this is the universal set. It's always important you put everything inside the rectangle or a square. Very important. Now the assignment stroke classwork. Exercise 5E, number 1 to number 10. on page 73. So thank you very much. I will be giving you the second part shortly.